Hey, welcome to this two-part free video on solving polynomial equations. Part 1 focus is on linear and quadratic equations, review of overall rules when solving equations. Part 2 is on polynomial equations of greater degree than 2, namely cubic and quadratic. So let's start with this example that is displayed on your screen. So this is an example that illustrates solving simple linear equation. 3x minus 2 is equal to 0. And you solve that equation by just simply rearranging it so you separate variables from constant values, and by dividing both sides by 3 you get the solution. So linear equation, the degree is 1, would have one solution, one real solution. Okay, no more than one. Okay, now on the next side of the screen, right here, we have a little bit more complex linear equation, and we will solve it also by first distributing 3x plus 3 comes from the fact that you multiply 3x times 3 times x and 3 times 1. So the next step is to add like terms. So 3x and x gave us 4x. And please note that we just copy the left-hand side without making any changes because we didn't do anything to this side. So 4x minus 2 is always copied the way it was given in the first place. Now 4x and 4x is the same term, equal term on both sides. So we can subtract 4x from both sides, and this would eliminate variable x. So the statement now says that 0 is equal to 5, which is not possible. Therefore, there is no solution to this equation. So now you understand that there will be a real solution to this equation, to any linear equation, or maybe there is no solution. So there's two possibilities. And finally, on this page, we will show you another example with fractions. Whoa! Who doesn't like fractions? I hope you do. Anyways, let's look at this equation, and since we have a fraction on the left hand side, you have an option here. You can multiply by 1 over 2 every term inside of the bracket and then work with that in the next step, or we can multiply both sides by 2, which would eliminate our fraction because the denominator is 2. So by multiplying both sides by 2, 2 times 1 over 2 will make that fraction disappear. So the next step is to eliminate the fractions. So this is why you have x minus 1 is equal to, and then when you multiply one side by 2, you must do the same thing to the other side. So this is why you have 2 times 2x gives you 4x, and 2 times 1 gives you 2. By combining x terms, you will have negative 3x, and by combining constant terms, you have 3 on the other side. Divide both sides by negative 3, and the solution is negative 1. Okay, so when solving equations, you must remember about two basic rules. The first one, BEDMAS. So when you're working with an expression, you must use brackets first, exponents, division, multiplication, addition, subtractions. Also, there are rules for solving equations, which are listed right here. You can add to both sides of an equation the same number. So this is, for example, when you're shifting variables from left side to the right side. This occurs because you add or subtract the same value to both sides of that equation. You can multiply both sides of the equation by the same non-zero value. This was applied in this example with fraction when we multiply both sides of equation by 2. You can divide both sides equation by the same non-zero value. For example, in the first question here, 3x is equal to 2. You divided both sides by 3 to isolate, to single out x. And you can put to the same exponent the same both sides of the equation, and there is a spelling mistake, and you know that we can fix this, and it meant to say put, okay, P-U-T. Okay, so next example we'll focus on quadratic equations. Okay, so 2x squared minus 5x minus 3 is equal to 0. So this is the equation of a second degree. Why? Because the variable x is put to exponent 2. So this is the next degree that we will be solving. It's quadratic equation because of the second degree. So we have two ways of solving that equation. The general equation is presented right here. So the coefficient in front of x squared is a, then b is in front of x, and c, the constant, is the number without the variable. So most of the time you want to see your equation in that arranged descending order. So the greatest degree first, the next degree, and the constant term. So we have a choice to solve this by factoring or by using quadratic formula. So let us recall the factoring. So you will be looking at the product, multiplying a and coefficient c. So that's the product. And also you will be looking for a sum of two same numbers that is equivalent to the value of that middle term b. So this is why you have the product is equal to -6, because that's the product is equal to -6 because 2 times -3, and the sum is equal to -5. So the two numbers that would satisfy the same condition, multiply to -6 and add to -5, are -6 and -1. So this is the beginning of the factoring, solving by factoring method. Now, using quadratic formula, if you prefer, and I personally like quadratic formula much better than factoring, because factoring is not always possible. It is not always that quick. So therefore, quadratic formula gives me always the solution that I want. So it is a very good idea to know this formula. So our coefficients a, b, and c are listed here because they are given in this equation. So a is 2, b is -5, c is 3. So the formula that we are using here is presented right here, -b plus or minus. Quadratic equation, therefore two real solutions. You can have no solution, you can have one double root, or two distinct roots. So this is why you have plus or minus. And the discriminant is b squared minus 4ac. Everything is divided by 2a, the entire sum or difference. So the next step will be to identify elements of the formula and replace with the values. So this is why you have -5 in bracket -5 times -1, because it's -b plus or minus, and we do substitute for b, for a and c, and right away you see that you have two real roots here, and square root 49, it's an easy number for us to calculate. So Moving down, you will see that I have a root, one root when x is equal to 3, and the second when x is equal to negative 1 over 2. So now, let us go back to solving by factoring. Okay, so the next step, once you have those numbers figured out, the numbers are negative 6 and 1, you always replace the middle term. Negative 5 you will show as negative 6 plus 1x, 6x plus 1x. So now we have 4 terms in this expansion, 4 instead of 3. So you can group them in 2 groups of 2. It doesn't really matter how you group them as long as you put in 2 groups. So from the first 2x squared and negative 6x, the common factor is 2x. So when you take this factor outside, you have inside of bracket 1x, because 2x times x has to give you 2x squared, and you have minus 3, because when you choose to multiply 2x times negative 3, you must get negative 6x. So the next group is x minus 3, and we put it in bracket. There you go. Now you can see that you have 2 identical factors, x minus 3 and x minus 3, right here. So now x minus 3 becomes a common factor. And then inside you put 2x, and you put, that was nice, and you put 1, because there was a coefficient 1, and there is 1 in front of any number. There's always that factor 1. So this is why you have x minus 3 outside, and 2x plus 1 is equal to 0. So the product is equal to 0, therefore you're thinking either x minus 3 is 0, or 2x plus 1 it must be equal to 0. Then you solve 2 linear equations now, and you get the solution. X is equal to 3, or x is equal to negative 1 over 2. It is exactly the same. In this case, we have solved this by using quadratic formula or by factoring, and we must get the same solutions, no matter how you do it. So, in the next video, we'll show you how to work with cubic or quadratic equations. But before you do that, make sure that you understand how to work with quadratic equations and linear equations. I think you have enjoyed watching this video. If you have any questions, post them right below the video. Any comments, go ahead and say anything, what you like, what you don't like about this video. I see you in the next video in a minute. Thank you. Bye.